My name is Ugonna Nwauche,
And my name is Umul Banin Jafri.
and our project was the single-cylinder oscillating steam engine. So this is our final product in the actual assembly workbench. As you can see, there are a lot of constraints that we used in doing this assembly. We did have a lot of trouble with the constraints while we were assembling all our parts together just because they weren't applying the way we wanted them to. For example, we had a lot of fixed constraints in the beginning just because we wanted to make sure everything was in the right orientation. However, a lot of those fixed constraints caused a problem later on with our angle constraints and some offset constraints that we had to apply as well. It was just turning into an over-constrained mess. But eventually we were able to go back and look at all the constraints that were necessary and were unnecessary, and we were able to get our assembly working properly. Another issue that we had as well was adding all of our standard fasteners to the assembly. On the dimensioned sheet that we were given, the specifications for the fasteners weren't very clear, so we actually had to go through CATIA's database of fasteners and just kind of find which ones would actually fit the assembly in regards to length and diameter. So that took a lot of extra time as well. We divided our assembly into 3 smaller sub-assemblies, which we will go into more detail about later on in the presentation.
So here's our first subassembly that consists of 2 parts, including 3 parts, including crankshaft, flywheel connected to the crank pin. The reason it was a fairly simple subassembly is because it didn't consist of any complex part. Considering the flywheel by itself, it was pretty straightforward to create. It just used the hold commands, and the circular pattern, which is the basic tools for CATIA. And also, talking about the crankshaft, it was fairly simple as well. It just needed just a single pad, and then use of one more circular circle, and then pad it. So overall, it was a pretty straightforward subassembly.
This is our exploded view drawing of the first subassembly. As you consists of 4 components: the flywheel, the crankshaft, the crank pin, and an M3x8 grub screw. All of these components are made of steel except for the flywheel, which is made of cast iron.
So here's our next subassembly. This subassembly was pretty straightforward and simple as well. And it consists of crank pin bearing. It is connected to crankshaft through a piston.
Yeah, this was a fairly simple assembly to make just because it consisted mostly of coincidence constraints and offset constraints. We did have some trouble with the 2 fasteners just because we had to go through I think about 20 different fasteners to make sure that we have the right size, and I actually think that the ones that we actually ended up with might be slightly too big. However, those are the ones that fit closest to our dimension drawing, so those are the ones we went with. This is our subassembly 2 exploded view drawing. It consists of 5 parts, and the materials included in this subassembly are cast iron, nylon, steel, and bronze.
So here's our third subassembly. This assembly consists of 1 cylinder, which is attached to the cylinder back block that is basically to support it and act as the backbone of the cylinder. And this subassembly, I wouldn't say it was difficult to create by itself, but we did have issues while putting it on the main product, attaching it with the main product of the project.
These difficulties mostly arose from the fact that we each made our parts separately, and so when we were importing them into the main assembly, the parts weren't always in the orientation that they needed to be in the actual main assembly. So that did cause some issues later on with our constraints. However, we were able to finally work around that. Again, with the fasteners, we did have a lot of trouble finding the right sizes, but we did eventually get the right ones. All in all, this subassembly was fairly simple, as they all were. However, when putting them all together in the main assembly, that's when we started running into issues. Another difficulty that arose while making the parts for the cylinder and the back block specifically is that they are connected by two angled holes. So normally holes are easy to make just because they're normal to the surface. However, these holes were different because they were to be applied at a 20-degree angle. After a little bit of trial and error, we were finally able to figure out a way around that. We made a guide curve that was angled at 20 degrees from the surface that we wanted it to be from, and we used that guide curve as a reference for the hole, and in that manner we were able to get the hole in the orientation that we needed it to be in for the assembly. Another issue arose while we were actually dimensioning our individual parts. Some of the parts are very small, and they have some very small chamfers and other dress-up features on them, and Katia had some problems dimensioning those in the drafting workbench. However, we were eventually able to work around that and get our dimension views correct. This is our third and final subassembly, and this is the exploded view. As you can see, these are the two angled holes that I mentioned before. And on some of the smaller parts, like I mentioned earlier, especially item 5 and item 6, there were some very small dress-up features like edge fillets and chamfers that you can't even see in this view just because they are so small. Another thing that happened while we were assembling this part was we originally thought items 1 and items 3 were the same part. However, upon closer inspection of the dimension views that we were given, we realized that they have slightly different dimensions. So luckily they're very similar, so it wasn't that hard to go back and modify the part to make it correct. However, that was just something funny that happened. Finally, this subassembly consisted of 8 parts, and the materials included in this subassembly were steel, nylon, bronze, and cast iron.
Okay, so overall the project went pretty smooth. I would say that because the only issues and the main issues that we faced was during the assembling the parts and during the assembly of the final product. Otherwise, when we were modeling the parts separately, there weren't any major issues other than that some of the dimensions were pretty tiny, and it was hard for us to actually get to the accuracy of that dimension. So that was the major issue in creating the separate parts. Also, I would like to include something we learned out of this project, and the main thing that we actually learned from this project is while doing the assembly parts, while making the sub-assemblies, we should take care of the constraints that we're doing and not over constrain them, and that which would cause a lot of problems that we faced. And also, before starting to constrain the parts, we should make sure that one of the parts is fixed in its place, so that wouldn't cause like issues later on. Like Ugonna mentioned before, that she had troubles while doing the sub-assembly 3 while and attaching it from to the main assembly. So that's actually what we realized by doing this project. Also, I would like to add that usually communicating with other team members and arranging meetings is the biggest group challenge that every team faces during the completion of the project. So hence, in the upcoming final project, we decided to start the project ahead of time and schedule the meetings accordingly. So and keep one another updated with the work we do, just like me and Ugonna did, and which worked out really well, and keep up with the good communication for future projects. So wrapping it up, it was overall a very great experience. We both learned a lot from this project, and that's all we have to say. Thank you for watching our video.